This is Math 8, Section 3.3. We're going to be understanding linear equations with two variables. So far, we've only covered things that have one variable, like an x or a y, but now we're going to be doing things that have two variables. So let's start out with considering a situation. From the book, it says, Dorothy has a younger brother, Benjamin. This table shows their ages over 5 years. Well, remember, if their ages, they're always going to stay the same age throughout those years. So we'll have Ben and Dorothy. And in 08, Ben is 1, therefore Dorothy is 4. In 09, Ben is 2, therefore Dorothy is 5. In 10, it's 3 and 6, 4 and 7, 5 and 8. Now most of you can already notice the relationship here because we know how the relationship of ages works. Every year, it goes up 1, 2, 3, 4, 5, 4, 5, 6, 7, 8. So we could already say that Dorothy is 3 years older than Ben just from looking at it. So we notice this pattern. So if we say that Ben is represented by X and Dorothy is represented by Y, we could put that into equation. We could just say that X, whatever Ben is, plus 3 is going to equal Y. Because if X is 1, 1 plus 3 equals 4. If X is 2, 2 plus 3 equals 5. And so it works for all of these equations here. And so we already just formed this linear equation from two variables. Let's try that in example 6. It says, write a linear equation for the relationship between hours and minutes. So we have two variables already, hours and minutes. Now we want to express the relationship. So we know that an hour has 60 minutes. So we could put this into an equation that just says H equals 60M. And that would be an hour equals 60 minutes. Well, an hour is equal to 60 minutes. So if you wanted to say, for example, 1 hour equals 60 minutes, and you put a 1 in for an H and a 60 for an M, and we multiplied those, that equation wouldn't be true. So sometimes you try it and you say, okay, that's not true. But if we say the hour times 60 equals the minutes, then we could say that's true. So we could say for 1 hour multiplied by 60, we have 60 minutes. And that would give us an equation that's true because 60 does equal 60. So sometimes you have to try it out to see if it's true. Let's try B. And so B says, Mrs. Ford heated a liquid and measured its temperature. She recorded the results on the table. Write an equation for the relationship between T, time, and temperature T. So we got time, and we got temp. Temperature is in degrees Celsius. We're going to represent that by T. So in this table, it says 0, 1, 2, 3, 4. And then for our temperatures, we have 25, 30, 35, 40, and 45. So we notice each time here it goes up 1, each time here it goes up 5. So, but how do we represent the relationship? Well, 0 plus 25. Okay, so we added 25. But here, if we take 1 plus 25, that equals 26. So that doesn't quite work. We couldn't say that. We have to come up with an equation that's going to show us this relationship. So how could we do that? Well, we could say 25 equals 25 plus 0, and that's equal to 25 plus 5 times 0. So notice they each have 25 in them, but this one has an extra. It's like 25 plus an extra 5. This one is like 25 plus an extra 5 and an extra 5. So this one is like basically saying 25 plus 0 extra 25s. This one is like saying 25 plus 0 extra 5s. This one's like saying 25 plus 1 extra 5. This one is like saying 25 plus 2 extra 5s. this one is like saying 25 plus 3 extra 5s. This one's like saying 25 plus 4 extra 5s. So sometimes writing these equations, you have to think through things, and it does take a little bit of critical thinking, but you got to follow the pattern and basically just see where that takes you. So we can notice the 0 matches, the 1 matches 2, 3, 4. So whatever this number is going to be equal to your temperature, T, and then whatever this number is going to be equal to this small one. So if we wanted to write an equation that told us T in terms of T, then our first one that's going to be on the side by itself is just the T. So in order to find this, in order to find this temperature, we would have to say, okay, well we know it's 25, but then we have to add whatever this number is, which is going to be T, times 5. A better way to write this so it doesn't look like plus and plus is going to be T equals 25 plus 5T. And that is the equation that works for every one of these. You can plug it in and check. If you put in 4 here, 5 times 4 is 20. 20 plus 25 is 45. And that works out. Try this in guided practice. See how it goes. 1 and 2. Okay, there is a way to do this on the graphing calculator, and we may get a chance to look at that in class, but for now, if you want to try it, you can read through the technology activity, see if you can do it. Let's move on to represent a linear relationship using a table of values. So we've already kind of seen tables, but we're going to keep doing that. So if we know that the sum of the angle of the measures of a triangle is 180, you can use this to fact the sum of the angle measures of a polygon with any number of sides. This is something you learn in geometry. It's kind of like a rule they tell you. So this rule is represented by a relationship. So S equals 180 n minus 2, where S is going to be the total angle and n is going to be the number of sides. So in your picture here, you can see like a triangle, you can see the pentagon, different things like that. So whatever number of sides it has, we're going to represent that by n. And then the sum of the angles is going to be S. So let's just make a table of values. If n is 3, because a line wouldn't be able to make a polygon, so we have to start with 3 because it has 3 sides. That's a triangle. And the triangle has 3 sides, so if we put 3 in here, it's 3 minus 2, which is 1, times 180, and so this becomes 180. If we have 4 sides, like a square, it becomes 360. If we have